Hey, all right, here we are for the final review for the course. This course this video may be a couple of videos, depending on how long it takes, because we're going to try to cover a little everything we did for the entire course, which so 15 weeks. Uh, Try to get through this quick. It should be a review, and you saw this in class hopefully already. But we start with the course introduction, and we remember we introduced the idea of SQL versus NoSQL, and these are the main two types. There's other stuff out there, but for the course, just worry about that. Uh, and that kind of broke down to the idea of relational versus non-relational. So we use SQL, structured query language, in relational databases, which is what this class is based off of. And honestly, it's what the majority of databases you're going to see out in the wild are if you're going to interact with, especially if you're like a business user or just an IT guy. Non-relational databases use other language of processing, and that's NoSQL stands for not only SQL. You may sometimes use SQL for that, but relational databases overview. Remember, relational databases or the RDBMS, that's Relational Database Management System. That's your SQL Server. That's your Oracle, your Teradata, your MySQL. They are not databases. They are relational database management systems, so RDBMSs. They store data in tables formatted in rows and columns when they're relational. Each row has a unique key to identify it. We call that the primary key. And tables contain specific types of information, usually, like a customer table, an order table. And rows in different tables can be related by the use of keys. So that's where your primary and your foreign keys connect. And tables are joined, and the return data is stored across multiple tables. Non-relational databases, they're built to overcome the limitations of relational databases in scale and performance, especially like in size and dealing with these large kind of unruly data types like video, images, audio, that kind of stuff, which is hard to structure. Uh, they're designed to be distributed across large data stores for large scale data needs. Uh, they do not replace relational databases. They are a complement to it. They're a more flexible data model that scales and can be modified dynamically. There's no fixed design. There's no tables to join. The main idea of it is flexibility and scale. So just remember, relational databases scale up, can only be as big as the machine they're on. You need to add things to the machine, whereas non-relational scale out. They scale out across nodes of, cheap use systems. Like Hadoop is a major thing to think about when you're thinking of that. All right. So let's go into what can go wrong. And this is where we start the idea of database design. So remember, when you're designing your table, on sometimes you're given a spreadsheet of data. Don't base it just on the spreadsheet form. Take the time to really read and understand the data. Don't base it on reports, because those are after the fact views. Really sit down with people, interpret the data, and try to see what maybe future uses will be out there, that kind of stuff. Really want to build your database so it's scalable and it's easily tweaked if you need to add or take things away from it. Don't just try to do a boilerplate. Don't focus on the immediate task at hand. Get to know the data deeply. Talk to the users. That's the main thing. Talk to your users out there. Focus on the types of data, not the current main use, and what kind of tasks are going to arise. Keep in mind, you're going to be doing the data development process, and these two, the use case and the diagrams, these are the abstract world here. Use cases are what we put together. That's your UML pictures. The diagrams, that's your ERDs. These are classes. It's not till you get into tables and actually building them down here that you have implementation. This whole area is actually where you're going to spend most of your time. So those are your questions mostly. If you're on your first pass, you've made your class diagrams, what you should do, you should go back, talk to the users, and probably review, make sure you're hitting all the right use cases. So most of your time will be spent in the top two boxes, revising. Unified modeling language used for use cases. You got the stick figure to represent users, and then you got each one of these bubbles represent tasks. Just understand what the UML is. You guys have all built them for your project, so you got that. The analysis steps, look at your use cases, make sure you know what tasks need to be carried out by all the people who use the system. And then the class diagrams, figure out what data is needed to be stored in order for these use cases to be used. And in chapter 4, we start to learn from the data model. The data model describes how the data is going to be stored for a real world problem. However, is not a complete and exact description of a real world situation. It's based on assumptions that may be incorrect, model of relations along the data items, and there's never a complete perfect model of a real world situation. The definition of scope solution needs to be clearly understood by everyone involved. And sometimes you actually want to, document the limitations of your data where things you're not hitting. Uh, you're building the data model. Keep in mind optionality. Optionality is the smallest number in the two number thing. It can be a 0 or a 1. In a situation like this, you can have a student who is not enrolled in a course. That's where you could have a 0. Because you could be a student who's not taking a winter course, doesn't take a summer course. That doesn't mean you're not a student. You're just not taking a course. You're not enrolled in a course in that spot. So you could still be a student, with 0. Well, you can't have a school with no courses, so this would have to be 1. So that's kind of the way to think about it there. Cardinality. Cardinality is the next number, and that becomes should it be 1 or many. And if you think of a reason why you would need 2, it's many. It's like for here, you go back here, can a student take many classes? Yes. If it was a situation where every student was issued a computer, like at my wife's school, all the kids get Chromebooks, but it's not going to have students not going to have many Chromebooks. They're going to get 1. So that would be a 1-to-1. Whereas 1-to-many, how many classes can you take students for this? Okay, so that's pretty much cardinality. So always remember the first number is ordinal optionality. It can only be 0 or 1. And the second number can be 1-to-many. Okay. And if you run into a many-to-many, that's when you got to break it off into an intermediate class. Get to know your data and relationship between the data. A data model works for a given set of assumptions and a problem scope. Always remember that. The data model is based on a set of assumptions. That's always the case. A program, everything is based on assumptions. So there is no perfectly clean, wild world open data out there. You need to determine whether the data should be shown as an attribute, class, or relationship. That's not order, right? So when you're looking at this model here, you'd have your class would be this box, your students, your attributes, again, would would turn into the columns. And relationship is the connection they have between them. So and that just kind of recovers that. Okay, so then we go ahead and keep in mind we had two things. We had chasm and fan trap. So you want to keep these in mind because they're probably going to pop up. The issue here is that you got this 1-to-1 and 1-to-1 here, both going into this division with these many-to-manys on the outside. And the result, you end up with this. So everybody goes to this single division, and every group is a member of this single division. So there's no way I can tell which group Bob belongs to or which group Sue belongs to because there's no way this path. So this is called our fan trap. The chasm trap's the opposite, where you can have a optionality of 0 into the middle table here. And then we end up in a situation here where you have like Anne doesn't belong to a group. So she's part of the 0 here. But each group has to belong to a division. So there's no way for me to know which division Anne belongs to because she doesn't belong to a group. Okay. Then the last thing, if you see this, just keep in mind this is you are self-relating in the table. And you get situations where you could have a team and you got the list of all the team members, and one of the team members is the team captain. So that would be self-relating there because you'd have another attribute that says maybe captain, and then you would link it back to the team member. Okay. Generalization and specialization, these are all based on the limited hierarchical qualities of SQL. Again, hierarchy is not as strongly enforced in SQL as it is in something like Java. But in specialization, if you've got a group of employees, but you might have one little difference about them. So everything else you're going to keep the same. Employee name, first name, last name, ID, might have date of hire, all that kind of stuff is irrelevant. That you'd keep the same. But whether somebody's a permanent salaried employee or a consultant that has an hourly rate and an end date, instead of just making the one table messy, you just split it off into 2 different tables. So you'd specialize into tables. Generalization, it's kind of the opposite, where you're going to push upwards. You'll take it out of here if you have a lecturer and student, which will both have an ID and a name, take them out of those tables and push them up into a table called person. And it's all a hierarchical thing. But like I say, the hierarchy is very limited in power within SQL. Normally if you're really trying to enforce hierarchy in a database, you're going to have to use some kind of other tools or other programming languages. All right. So again, generalization and specialization are inheritance. You have some subclass, sub B and subclass C are both specialized classes of superclass, and subclass B will have all the attributes of superclass into the addition of their own attributes. Okay, just keep in mind, you guys should know this, but class on a model, so your classes will become tables. The attributes become fields. The relationships become keys, foreign keys and primary keys. You got the one-to-many relationship uses a foreign key table with one relationship. Many-to-many, you need to put an intermediate table in with two foreign keys. If you have an optionality of one at the end of the relationship, you make the foreign key required, and parent and child classes of inheritance. Primary key is your identifiable key. This is a thing that, and I always say, think about your student ID number or think about your driver's license number. It's a unique number that identifies you in a database. That's what identifies the row, because there can be plenty of people with your same name. You cannot have a duplicate in the primary key column. Primary keys all have to be unique, and they can't be null. You can have concatenated keys where primary keys are made up of a combination of fields, such as you'd have student in the class they're taking, maybe even the year. So you could, that would make a concatenated key. I strongly advise against them in this class, especially, but hey, foreign keys that's the key. That's how we do our connection from another table. So what you've got a foreign key is referencing a primary key in another table, and that's how you make the two. That's how your relationship happens there. They would have another ID down here to let you know that's how you connect to that table. There'd be another field. It would be a foreign key to connect to this primary key. So that's the main thing with foreign keys. Referential integrity is a constraint that will not allow you to choose something. So if you have a table with NBA basketball teams, it wouldn't allow you, and you try to type in the Montreal Ducks, it's not going to work because that's not a team. That's not in the list. It would violate referential integrity because you're trying to put in a foreign key that doesn't relate to the primary key of another table, of the table it's related to. One-to-many relationships like this, what you do is you end up, in many-to-many relationships, you end up having to put in a referential table. So if you got these tables here, cocktails and ingredients, but you want to make a recipe, so you'd put in a recipe table. Because otherwise, that's really the only way to get the real many-to-many relationship. So this middle table here, this has two foreign keys. So it relates to cocktail ID and your ingredient ID. Again, we've all done this. You had to do it for your project, so you should know about reference tables. Normalization, this is the process of structuring a relational database to reduce data redundancy and improve integrity. It's a formal way to check the fields of the right tables and help determine whether you need additional tables. A rule of normalization is you have to have some kind of primary key because you have to identify. Again, primary keys, as we say in this class, are required, but in reality, you can have tables without primary keys, but you cannot have a normalized. You cannot be in third normal form if you don't have primary keys. And just think, we worry about three normal forms: first, second, and third. That's what we're all worried about in this class. There are other ones, but don't worry about them. And let's try to do a quick burn through this. The first normal form, I think, is the easiest to remember. You can't have multiple values in one column here. So you got this nursing developer, blah, blah, blah. This is not first normal form. What you got to do is you got to break this apart so you have individual atomic values in the table. So there you go. So now we have a table with atomic values here. So we took this and we moved it. So if you see a column with commas, yes, that's not first normal form. Will you see this in the real world? Yes, all the time. But this, third normal form is an academic concept mainly. So, but for the class you need it. So this is first normal form. So that's the first thing to check for first normal form. Okay. Second normal form involves looking at keys. So when you have multiple keys, especially a concatenated key, like we're using here, which is employee and project number, can I gather information about one or the other without look, So you'll notice the projects number are related to a project name and a contact. Okay. And you'll notice the contact is related to the project number because you got two different employee numbers here, and they got two with the same phone number. So basically, I can gather these three rows can all be gathered by just looking at this project number. I do not need to know what employee or any of this stuff. So this case right here tells you if I can look at one part of the primary key and get other rows to see, then it is not in second normal form. So what you'd want to do is break that apart. So you'd have employee, and then you have a project number table. And the simplest thing is if you have a single primary key, your second normal form is good. So, and also keep in mind, in order to be second normal form, first thing you have to do is you have to be first normal form. So you can't have one or the other. It's first normal is required to be second normal. That's probably the most important thing to remember for this course. So we'll go ahead. We'll get into third normal form. Third normal form. Now we're looking at non-key. So we've got here our employee ID is our primary key. So let's look at all the non-key columns. Well, the employee ID 101, we know it's John Smith, and he's in Department 2. Same thing with Susan. But we've got here is this other column with marketing. Well, this tells us that Department 2 is marketing, and Department 1 is sales. Well, I don't need to know anything about the primary key. Those two things verify off each other. So if I know it's Department 1, I know it's sales. If I know it's Department 2, I know it's marketing, and vice versa. I don't need the primary key. So if I do not need the primary key to understand the information right there, that can be brought so now that's transient or transitive information. So we bring it over here and we set up another table. But like I say, for the final, I'm going to tell you the most important thing to remember is if you're second normal form, then you have to be first normal form. If you're third normal form, you have to be second and first normal form. Okay, you can be first normal form and not be second or third, but you can't be the other way around. So second infers your first normal form, and third infers you are second normal form as well. Okay, so again, primary keys, keep those in mind, can be a combination. Each key is a unique value and used to identify rows, and it's used to set relationships between that and foreign keys. Constraints we can have out there is unique constraints, things like you can't have a combination. So I've got these farms and paddocks 1 and 2. I can't have a combination beyond that. I have to make sure they're a unique combination. That's just a basic constraint you can set. Some rules on constraints, how you can get rid of them. In this situation here, let's imagine that that Susan Jones quits. We want to remove her from the table. The problem is this table over here has a 19 in it. So this will break the table. This will break the relation because so there's a couple things you can do. You can disallow the delete. You can sit there and say, I want to delete this row. It's going to go and look and say, is there a 19 related to any related table? There is. Yep, you cannot delete this row. And it'll tell you have to go back and fix this first. You can nullify a delete, meaning if I delete this row, this right there, this 19 will turn to a null. You can set the trigger up that'll cause that. And finally, you can have a cascade delete. Or if I delete this row, it'll go through and delete every row where there's a 19 reference. So just keep in mind, those are some ways you can deal with that. Querying basics. Again, we kind of learned this the late way. We went the other way. Just remember, select and from are kind of the two main ones you need. Where, group by, I don't like this. Order should be behind it because order is always last. Inner join, and then union. Remember, union's actually not a join so much as it's combining two different tables or queries that have to exactly match. This is not important because we didn't go over that anymore. And other methods, object-oriented databases, spreadsheets, XML. We kind of went over this a little. I mean, this is more complex. This is just Excel, and this is XML. I'm going to add JSON for next semester because it could be. All right, where are we at? All right, we're in 19. I'm going to pick up the next meeting, next one next. Okay, so we've got to stop recording.